Yeah, wait a moment. So in the unit number one, we are having so many things to draw on the drawing sheet. Remember, uh, ellipse, cycloid, parabola, hyperbola, so many things. Scales, construction of scales. Okay, plane scale, diagonal scale. Okay, so many things are there. Cycloidal curves, cycloid, epicycloid, hypercycloid, and so on. Okay, so before going to that, yeah, what is the nature of our drawing? What we supposed to draw on the drawing sheet? Okay, such things, such basic aspects I would like to explain in this particular class. Okay, now let me share one screen. Uh, is the screen visible to you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah, can someone can read the problem? I think first unit, unit number one, this is the first problem. Okay, so first I would like to read. Read along with me. Construction ellipse when the distance of the focus from the directrix is equal to 50 mm and eccentricity is 2/3. Okay, 2 by 3. So here we need to construct an ellipse. Okay, we need to construct one ellipse with help of the mechanical tools, instruments, drawing board, drawing sheet, clips, everything you need to use and you need to draw along with me. Those are having instruments, and if you're ready, please set your drafter, fix the drawing sheet on the drawing board. You can practice along with me. If you are not ready, just follow what I'm saying. Maybe at least for the next class, you must come with preparation, fully equipped with the instruments. And if possible, whatever I am saying today, you come practice and show me the drawing sheet in the next class. Okay, not today, maybe uh, immediate class in the next week. Okay, so I will explain everything, don't worry. Uh, and I will give you some basic introduction to conic sections also at the end of the class because you are bored of so many introductions, right? So I would like to go into the subject and practice session, what you're supposed to do in the drawing exams. Okay. So in the drawing exam, there is no theory questions. Okay. Only you need to draw some figures on the drawing sheet. Okay. There will be no theoretical questions you need to write on the paper. Okay. So construct an ellipse when the distance of the focus from the directrix is equal to 50 mm and eccentricity is equal to 2 by 3. And you are familiar with eccentricity of an ellipse. Generally, it is less than 1. If you take parabola equal to 1, if it is a hyperbola, it is greater than 1. At least much input you know, right, from the previous studies. In the intermediate, you can see that ellipse eccentricity of an ellipse is less than 1. You know the formula for ellipse also, but we are not interested in those formulas. Okay. Now, suppose eccentricity is given 2 by 3. Okay. So I will explain what is PF, PC. Okay. What is 2 plus 3 later. Now, before that, you see my screen. Uh, I have drawn one axis line. What is the length of that axis? Any idea?
Infinite.
Infinite. Very good. Axis doesn't have any length. For conveniently to draw on the drawing sheet, we will take some length. Okay, we call it as axis, C axis. Okay, or CA. Then I have drawn one vertical line also, right? Perpendicular to the axis. A, A something like this. Okay, this vertical line, I call it as directrix. What is the length of the directrix?
Infinite.
Yeah, it is of larger value, infinite. So I will draw two lines like this. Then you understood these two important lines, axis and directrix. Now I have kept a point on the axis at a distance 50 mm according to the problem mentioned in the problem. Just I am reading you for you one more time. Construct an ellipse when the distance of focus F, capital F, focus from the directrix is equal to 50 mm. Okay. So now what you have to do, take your pencil with the help of mini drafter, take 50 mm or 5 centimeter. So general I will tell in millimeters only, 50. On the axis you need to locate the focus point as per given in the problem. So the distance is 50. So those who are having drawing sheets, and if you're ready, you can draw along with me. It's easy for you to complete this ellipse. So don't postpone the work. Today's work you have to finish today itself. That is a good habit. Okay. And if you show me the drawing sheet completing these particular assignments I am giving on the same class, you will get 15 marks. 15 marks. So for every class you will get 15 marks. I will take average of all 15 marks. So that is the day-to-day work assessment. Okay. So for today's class, we are having two classes, I think. Okay. So classes, if you complete, okay, what are the problems I am giving? If you complete on the drawing sheet, okay, if you draw along with me, then it is possible. Okay, then you will get 15 marks. Suppose if you show me these assignments maybe after next week, okay, then you may not get maximum 15 marks. You may get 12 marks or 10 marks, something like that, according to the neatness you maintain, according to the drawing standards you have maintained on the drawing sheet. Okay, so maybe next time please repeat. Please don't repeat like this. Come with all the instruments and all. I hope I explained previously what are the instruments required, what you need to buy. Okay, so maybe I am expecting at least for the next class. Now listen
Sir,
carefully.
is buying the drawing board necessary?
It is required because your household tables are very rough and very hard. So if you keep on it a drawing sheet, the pencil is also having soft, okay, grade pencils we are using, right? So the exact impressions may not reflect on the drawing sheet. So you better you go by a new drawing board if you can afford. Okay, if
How much it can be, sir? Like around.
1,000, 1,500 like that. So you have to see.
Okay.
Uh, yeah, the
Okay.
next
No, no one
important.
is having the estimation.
Yeah, we will give you one more chance to you. Okay, you can come with all the instruments. At the end of this class, maybe in the next class today, I will brief the instruments required for the preparation of the these technical drawings. Okay.
Okay, sir.
Yeah. Next important point, focus. We need to locate the axis at a distance of 15 mm, 50 mm given in the problem. Then the next important step. Just remember these steps. You can easily complete the this elliptical curve. Okay. So this is one of the engineering curves. Where we will use these engineering curves, we will discuss later. Okay. First, interestingly, you follow this particular step-by-step procedure. Then you will have some uh, importance of these curves in the later stage. Okay, now eccentricity is given 2 by 3, generally less than 1. It can be 3 by 4 or 4 by 5, whatever the value may be, that will be less than 1. So if it is 2 by 3, it is, see, you see the value 0.667, it is less than 1. Now, whenever it is given 2 by 3, what you have to do is add numerator and denominator. 2 plus 3, 5. Okay. So, CF distance, 50 mm distance, you need to divide into 5 equal parts. Okay. I will tell you why 5 equal parts. Okay. You will understand at the end. Okay. Then what you have to do? CF distance, you have to divide 5 equal parts. So 2 by 3, 2 plus 3, 5. Suppose if it is 3 by 4, 3 plus 4, 7 parts. You have to divide this length. Okay. The length can be 50, 45, 55, whatever it may be. Do not worry about the focus distance. We are having line division method, right? How to divide a line CF into 5 equal parts? Do you remember line division method? How to divide the CF into 5 equal parts?
So 50 by 5.
No, not like that. We are having one procedure. Okay. What you have to do is you draw, I will tell you, give me 1 minute time. So if you use calculator, it is simple, but in our drawing, you should not use calculator. To divide this CF distance into 5 equal parts, what you have to do is you need to draw one angular line. One angular line. Okay. One angular line. On that, you need to mark 5 equal arcs. 5 equal arcs, because we are doing only 5 parts. 5 equal arcs we have to draw, and the last arc you need to join to the focus. Okay. If you want clarity, I will show one more screen. So I will open some paint. So if I try to uh, draw something on this, suppose this is the directrix, this is the focus, right? What I am saying is this is the focus F. Yeah, my screen is visible to you.
Yes, sir.
Yeah, what you have to do is this distance is CF 50, right? So to divide this into 5 equal parts, n number of equal parts, that n will be 5. 2 plus 3, right? 2 plus 3. This is as far as eccentricity of an ellipse is concerned. Okay. Now, how to divide this CF is equal to exactly 5 equal parts. In advance, the distance is 50. Okay. 50 by 5, 10 millimeters, right? You can directly keep 10, 10, 10, 10. But in engineering, that is not accepted, because suppose the value is 55. Okay. 55 by 5 means 11. Okay. Accepted. Okay. But if the eccentricity is 3 by 4, 3 plus 4, how much? 7, right? 50 by
Sir,
7 is 50 by 7. You won't get exactly 10 mm or 5 mm or 11 mm. Okay, you will get some fraction. So that's why we are not accepting using calculator. Okay, simply marking 10 mm, 10 mm, 10 mm like that. Okay.
sir,
So yeah, please tell me.
sir, can we also divide by ratio and proportion?
No, not accepted. There is a standard in our engineering drawing. We need to follow that standard. For that, what we have to do is from C, you draw one inclined line of any length, and of any angle theta, any angle, theta. Generally, the theta lies in between 90 degrees and less than 90 degrees, okay, and 0 degree. In between 0 and 90, you can use any value here, okay, of any length. Remember, this is important thing you need to learn. This is useful for dividing any line into a number of equal parts. Now our line is CF. We are dividing the CF line, okay, CF line uh, into equal number of parts. Now, after drawing this inclined line, okay, that can be any angle in between generally 0 to 90 degrees. as per your space availability in the drawing sheet. Okay, you can take 30 degrees, 45 degrees, or any value. Okay, then take your compass, draw equal arcs, 1, 2, 3, 4, 5 arcs only. Okay, remove the rest of that line, remove the rest of that line. Okay, how many arcs I have drawn on this line?
5.
5.
5.
Yeah, why 5 means we are dividing the line length into only 5 equal parts because of the eccentricity is equal to eccentricity given in the problem E is equal to 2 by 3. Okay, that's why you need to take only 5 arcs. Now, can you tell me what is the distance between these arcs? What is the radius of your compass while drawing these arcs?
Sir, any radius?
Yeah, if you first initially you set any radius and don't change that radius, okay, draw remaining arc so that each the distance between each arc will be same. Okay, now understood up to this?
Yes, sir. Yeah.
Yeah, then
Yes.
now you are having one arc here, second arc here, third arc here, fourth arc here, and fifth arc here. The last arc, what you have to do is you need to join to the, with ordinary scale, you need to join to the other end of the line. So CF is our line, right? The other end is F. Okay. That line CF is having initial C point, end point is F. You need to join the last fifth arc with help of ordinary scale, join to the other end of the line to be divided. Okay. So I have joined with ordinary scale. Okay. Now you are having mini drafter, right? Then the mini drafter plays vital role here. Mini drafter is having L type of scale, right? So in that L type of scale, you will fix any scale, either L shape. You are having L in the shape of L. There are two scales, right? So you can match any one of the scales to the mini drafter. Okay, that means you have to fix the drafter scale to this particular line, match this line, whatever the inclination it may be, just match your drafter scale to this and move that and tight the mini drafter knob. Okay, you need to tight the mini drafter knob, and because the drafter you are fixing to this matching to this scale, right? Mini drafter you are fixing like this. Okay, one of the scale is matching to this particular line. Okay, now what you have to do is just move the mini drafter scale parallel to that line from fourth arc. Okay, and from third arc, from second arc, from first arc. So these lines are parallel to the first line you have joined with the ordinary scale, right? So you need to move the drafter parallel to the first line. So by doing so, what you will get is you will dividing this total CF length, okay, into exactly 5 number of equal parts. 1, 2, 3, 4, and this is the 5. Or I can write 1, 2, 3, 4, and 5. Now if you measure with any compass or divider, the distance all parts, the length of each part is same. Okay, that is the advantage of this method. Do you have any question here? This is called line division method. Line division method. You can divide any length of a line into n number of equal parts without help of any calculator or mathematical proportions. Okay, or similar triangles. No concept is required here. So importantly, you take any angular line, divide that into 5 equal arcs. Okay, you set any radius 1 centimeter or 1.5 centimeter as per the space availability. You can draw equal arcs. Don't change the radius while drawing the arcs. After getting 5 arcs, the last arc you have to join to the end of the line CF. So F is my end point. C is my initial point. So from C, you have drawn angular line, and at the end of the line F, you have joined the fifth arc. Parallel to that line, with help of mini drafter, set your mini drafter scale matching to that particular line. Tight the mini drafter knob and move the drafter from fourth arc, third arc, second arc, and first arc. Okay, in that way you can able to make up the that you can divide the particular given line into n number of equal parts. So any question here? You understood clearly, right?
Yes, sir.
Yes, sir.
Sir,
Yes, sir.
Yeah. So I will go back to previous section now. So I am not showing you here. Simply divide. I have divided 5 equal parts from C to F. 1 point, 1 part, second part, third part, and fourth part. The next step, remember, what I have to do is I have to locate. I have to locate. I have to
sir, your
locate.
voice is breaking, sir.
My voice is breaking. Maybe internet issue. Since I am not breaking myself, maybe internet. Yeah. Sometimes we have to adjust. Now you see here. I will show you this video once again. Divide CF into n number of equal
Sir,
parts. Yeah, can you ask me after 10 minutes?
yes.
Yeah, please complete me this ellipse. Then you will have a number of questions. Okay, I will clarify those doubts because some of you are in line with me. So now here, why we have divided 5 parts means the eccentricity is the property of the ellipse. 2 parts, numerator is 2 parts, denominator is 3 parts. So what you have to do is we have to find the vertex point. You have to find vertex point exactly 2 parts focus. 2 parts away from focus. Remember, numerator 2, numerator of eccentricity 2 by 3. 2 you have to remember. Okay, and from focus you need to leave 2 parts. Mark vertex. V is nothing but the vertex. Okay, now after locating the vertex point, what you have to do is you need to draw one more perpendicular line from vertex. How much length VE? That depends on the distance of VF. So take VF distance equal to VE. Okay, and I will tell you the next step. Join C to E and extend one inclined line like this. Okay, join C to E and extend one inclined line. Then the next step is you can take any length of that line. Okay, the next important step is you need to mark any number of random points after vertex point. So remember easily, just I am uh, elaborating the procedure step by step. So after vertex point you can choose a number of points. 1, 2, 3 may not be equal distances. Unequal distances also you can choose of equal points. So I have taken this. This is the first point. Okay. Then focus itself is the second point. Next I have taken so many other points. Okay. Here I am showing you equal distances, right? But in general you can choose unequal distances also. Okay. There is no rule like you need to maintain 1 centimeter gap. Okay. So all these lines are after vertex point. You can choose a number of points and you need to draw vertical lines like this, intersecting with the C extension line. Okay, you have to extend. You have to draw all vertical lines from various n number of points you have chosen on the axis. You need to drop vertical lines like this. Okay, and in engineering, our subject numbering system is very important. I have to write numbers after vertex. I have taken one point here, second point, third point, fourth point, sixth point, like that. I have taken a number of points, and uh, I have dropped vertical lines from the 1, 2, 3, 4, right? So these vertical lines are intersecting this C extended line, right? At various points. Suppose 1 is intersecting the extended line at 1 dash, 2 at 2 dash, 3 at 3 dash, fourth line at 4 dash, fifth line at 5 dash, so on. Okay, then your job is almost over to get the ellipse, that curve. Okay, only the last important step is you need to take your compass, set the radius 1 1 dash. This is the first radius, 1 1 dash. Okay, and take your compass, set this radius 1 1 dash, and center of the compass is always focus, is always focus. Cut this 1 1 dash line above the axis and below the axis. Now I will show you. Observe the screen clearly. Take an arc of radius 1 1 dash is the first radius. Focus Focus is always center. Put arc with focus F as center always. The radius are changing. First radius is 1 1 dash. Second radius is 2 2 dash. Third is 3 3 dash. So on. The radius you need to change, but always while cutting the arcs, you have to maintain focus as the center. So this red point is there here, right? Okay, that is the focus, which is at a 50 mm distance. Okay, now take your compass, set the first radius 1 1 dash. Okay, focus center, cut the first line. First line means what? 1 1 dash line. Okay, so here your compass, you cut this line with the 1 1 dash radius. Here one arc, below the uh, axis you draw one more arc on the same line. Okay, you can observe like this. Have you seen these arcs here? Are you able to see the screen clearly? Here one arc is there, one more arc is here. Okay,
Yes, sir.
focus is the center. For drawing these two arcs, what is the radius? 1 1 dash. Okay, so from 1 on the extended line, this vertical line intersecting at 1 dash. So you choose the radius 1 1 dash, focus as center, cut that line above and below. Okay, if you repeat the procedure, that means 2 2 dash is the next radius. Focus here, accidentally it is second line is matching with the focus line. Okay, so directly you can choose focus as center, and 2 2 dash is the radius. You cut the same line above and below. Okay, you can choose these points at anywhere. Okay, need not be passing through focus. Okay, now if you keep on doing such procedure, 3 3 dash is the next radius. Focus, now you see the focus is here. 3 3 dash you need to draw arc from focus is the center of the compass. Don't draw from 3 as your center of the arc. Okay, focus is the center of the arc always. Okay, but the radius is 3 3 dash. If you do so, you will get so many number of arcs like this in the shape of ellipse, in the shape of ellipse. So gently put all the points P1, P2, some numbering system you need to give. Okay. Now, what happened? I have taken HB pencil. All other lines are 2H pencil, light, okay, pencils I have to use, but while drawing this ellipse, I need to use HB in a single stroke. Okay, don't draw two times or three times. Okay, in a single stroke, uh, passing through the vertex is the passing through the vertex. This is the starting point of your curve. Okay, you need to join all these arcs. Okay, join all the arc is intersecting this vertical line at a particular point. Okay, passing through all those points, you need to join with a smooth curve with free hand only. Don't use any French curves or something like that. Okay, use your free hand in a single stroke. Passing through vertex is the initial point, and already we have got so many points of arcs, right? Intersection point of arc with vertical lines. So those points you have to join with the smooth curve. That is the elliptical curve. We have many applications in the outside world. We will see later. So this is the ellipse. Now we will discuss what happened actually, what is the eccentricity 2 by 3, what is the property here, how to analyze that properties we will see. Okay, then now I would like to tell you, so you need a number of points to complete this elliptical curve. Okay, suppose you have taken initially 9 points. If the curve is not closed, you take two more number of points, you will get the complete curve. Okay, like this. uh, you may get 11 points, 12 points, 13 points. Okay, if you take the distance between 1 and 2 very close, you may have 20 points, something like that. Okay, and this is the initial point, which is on the axis is the vertex 1, and this is the vertex 2, or I can call it as V and V dash. Okay, so V and V dash is nothing but the major axis. Okay, and you know exactly at the center of major axis, if you draw one vertical line, that is the minor axis. Okay, now here I told you this is the directrix, some three parts away from vertex, right? The directrix is three parts, one, two, three parts away from the directrix. Okay, and the vertex is two parts away from focus. So by symmetry, you can take one more directrix here by taking three parts, one, two, three parts here. Or you can measure the distance between V and C. You can take V dash and C dash to the right hand side. You can draw one more directrix. So you can have vertices, right? Two vertices and two directrices, right? And one more thing is, I have located only one single focus here, and focus is at two parts away from vertex, right? So you can select one more focus from the other vertex by leaving two parts, or you can measure the distance between V and F with your divider or compass. You can transfer the distance here somewhere. You can locate one more focus. Okay, and there are so many other properties I would like to show you. Uh, Before going to that, we will see how to construct a normal and tangent. Okay, here you see to 1 minute. Yeah, I think you are able to see the total screen. Now here, if you take any point on the curve, elliptical curve, I have taken this point. Simply join that point to focus. Okay, and you will get one line here. Okay, for that line, you draw one perpendicular onto the directrix. Okay, like this. Are you able to see this perpendicular?
Yes, sir.
Okay, first what I have taken for getting normal and tangent at any point on the curve, I have taken selected one point here. Okay. From that point, I join to focus. You will get one line. So what you have to do is for drawing one perpendicular to this particular line, you can use protractor, or your mini drafter is in the shape of 90 degrees. Okay. Or your mini drafter scales 90 degrees to each other, right? So you match one of the mini drafter scale to this line, and other line automatically gives you perpendicular. Okay. That will hit the directrix somewhere. Okay. That is the tangent point. And simply join the tangent point to the point we have already selected on the curve. So this is nothing. This line, green color line, is known as tangent. Okay. And normally, exactly these are perpendicular to this tangent. Okay. From the same point. How to draw that perpendicular? I told you, if this is the tangent, match one of your mini drafter scale to this tangent. The other scale automatically shows 90 degrees. Okay. That is the normal. In this way, you can able to make up normal and tangent at any point on the given elliptical curve. Okay. Let us see some other properties. Yeah, property 1. Here, the ratio 2 by 3 is constant. Anywhere on the, at any point of time, or anywhere on the elliptical curve. If you choose any point on the ellipse, okay, the distance I will show you here mathematically, the ratio. Now you can understand what is this 2 by 3. 2 indicates PF, right? Now I will tell you where is PF and PC. Here I have taken a point P somewhere here. Okay, P somewhere here. You are able to observe my screen or not? Please please tell me any problem. There is a point P on this ellipse. On this ellipse, I have taken one point P. Join that point P to F. These dotted lines I am showing you here. This is the numerator. This is the numerator. 2 units. Okay. And from P you draw one horizontal line. That is the denominator. Okay. The distance. Okay. That is constant anywhere. For example, if you take the point to along the same curve, it will become vertex, right? It will become vertex. If P comes here, P becomes vertex. So the definition is VF by VC. VF by VC. So VF, as you know already, the total distance is 50. What is the distance of VF? 20, right? And VC?
20.
VC 30. So VF by VC 20 by 30 means 2 by 3. 2 by 3. That means if vertex moving from here to somewhere P, okay, even though this PF is increasing and this PC is also, PC1 is also increasing. So the ratio never changes. Like that, the ratio become constant. Okay. In this way, you need to understand that is the property of an ellipse. The eccentricity value will not change. If it is 2 by 3, that means less than 1 or 0.007, that ratio, even though point is moving from vertex to somewhere, okay, the ratio, the numerator divided by denominator will not change. I will choose one more point somewhere, okay. For example, I am choosing somewhere here. I am joining that point to F. Now again, this PF, P to F, okay. I have taken some other point P2. Earlier it is P1, now it is P2. Now you see P to F is increasing. And if you draw from P to U one horizontal line, okay, like this. And this P to C2 also increasing. Yes or no? P2, C2 also increasing. But what is the definition of eccentricity? Okay, that is eccentricity definition is Vf by Vc. That means P2f by P2C2. Again, that is constant. Even though P2F and P2C2 increases, numerator is increasing, denominator is also increasing. So the ratio is same, constant. If the ratio is not same, obviously it is not an ellipse. Okay, so the property of an ellipse is the ratio must be same at every point of time. So in a special case, this point comes to the vertex. Okay, vertex. The property of vertex is a point on the curve as well as a point on the axis. And you will understood now the ratio why we are dividing two parts and three parts. Okay, total five parts, because the eccentricity is nothing but this any point on the curve to the focus divided by the distance of that point to the directrix. Okay, that is the definition, basic definition. So accordingly, this property is we that is the property number one. Now property two. For example, if you take any point, okay, we already discussed this is a focus one. There is one more focus. Due to symmetry, you can locate VF and here also VF. Okay, second focus you can mark here. Suppose if you take any point on the curve, okay, let us take any point P3. Okay, P3. If you uh, take the sum of P3F and P3F dash, okay,
Equal to
if you
major
take,
axis.
hello, no, yeah, 1 minute, yeah, if you join P3 to F and P3 to F dash, if you add these values, the distances, these two distances,
So I see sum of
P3F and P3F dash is equal to, now you can tell me, is equal to
length of major axis.
length of the major axis. Where is the major axis here? V2, V dash, V2, V dash. Now the major axis is V2, V dash. So that is the property. So here I am writing P3F plus P3F dash is equal to VV dash, length of the major axis. So if we understand clearly these properties and how to draw this ellipse, I need not explain the second problem, parabola, third problem, hyperbola. Simple difference, okay? If you understand this total picture, you can easily draw the rest of the parabola and hyperbola, okay? So, uh, do you have any questions now? You can have, I can clarify them.
Sir,
Yeah,
you said we have to draw the ellipse with HB pencil.
okay.
So does that mean all the remaining lines we have to draw with 2H pencil?
Exactly, exactly.
Okay.
2H only because we don't want to highlight all other lines. Those are known as construction lines. Our important line is elliptical curve.
Okay.
Okay.
And one more question, sir.
Yeah.
This while dividing the line CF into five parts, we drew that arc, no, sir, like five arcs we drew and that we
Yeah.
joined.
Yeah. Yes.
Should we erase that?
No, no. Keep it
After,
there because no. You have to keep it there with the 2H pencil. You need to draw. Okay. Don't erase. Whatever you do on the drawing sheet, don't erase
okay.
because for such construction work, okay, you will be given some marks.
Okay, sir.
Don't erase anything. We have done to divide this line into five equal parts. We have drawn some angular line, so many five arcs. Okay, we have drawn parallel lines. Okay, all are required. Okay, all are required. Don't erase.
Okay.
I have not shown you here, but you have to show. Yeah, any other procedure, any procedure difficulties? Okay,
Sir,
yeah, please,
sir,
yeah,
excuse
yeah,
sir,
please.
the part where you use intersection points for drawing the ellipse, can you explain the one part again, sir?
Yeah, first, uh, so after dividing five equal parts, we will take VF distance equal to VE, two parts, one vertical line and one VF. There is what is the distance of VF, which is equal to distance of VE. We will draw some extension line. After vertex point, I can choose n number of points like this. Then first radius is this is your doubt, right? First arc how to generate, right? First arc, yes or no?
Yes, sir, yes, sir.
Yeah, 1 1 dash you take with compass. First radius is 1 1 dash. So these 1 2 3 4 5 6 7 points you can choose randomly. Need not be spaced equally. Okay, you can choose a number of points. So the first radius of your compass is 1 1 dash, and focus is your center. Focus is your center. Okay, draw two arcs like this. From focus as center, draw one arc above the axis and one arc below the axis. Same line, 1 1 dash line. You will get one point here, other point here. Vertex is the initial point. So you have to repeat the procedure to get the so many number of points. Yeah, any other question?
Sir, the length of VE should be
VF, VF, VF.
VE. I mean,
Yeah, VE
line.
is equal to VF. Okay, CE, if you simply join C to E and extend that line further, there is no restriction of that length. Okay.
Okay, sir, thank you.
Yeah, any other question? No other questions?
Sir,
Yeah, please tell me.
the distance between 1 dash, 2 dash, and 2 dash, 3 dash may not be equal, na sir?
Yeah, may not be equal. I have shown you some equispaced lines, but uh, you can take randomly choose one point here, second point here. The distance between 1 and 2, 2 and 3, 3 and 4 need not be same. Okay. If you are interested to take equal distances, you can take equal distances, no issue. Need not be same.
Okay, sir.
Any other question? And you watch all these videos at the end of the class. Once again, you can uh, watch it again, and so that you can clarify so many other doubts. Okay. So importantly, the distance CF, you need to divide 5 equal parts. So after 2 parts, you have to locate the vertex V, because numerator is 2. Okay, in case of ellipse. So this logic you need to apply for the next problem. Okay, same procedure, same procedure you need to adopt. Okay, while locating vertex, here I have taken 2 parts leaving from focus, but in case of parabola, where we need to locate vertex. In case of hyperbola, where we need to locate vertex. That is only changing because of the eccentricity values need not be 2 by 3 for parabola, and hyperbola need not be 2 by 3. It is something like greater than 1, right? Hyperbola, at the time 3 by 2 will come. So you need to leave 3 parts from the focus. Then the vertex is shifted to here. Okay. And VF distance now increased ellipse, right? So similarly, the vertical distance V is also increased, and the C extension line will go like this, not like this. It will go somewhere here. Okay, we will discuss all those differences maybe in the next problem. I think you can able to make up, right? Can you do
Yes, sir.
on your drawing sheet? Okay, this is our main ellipse, and this is the drawing normal and tangent, and these are the important properties we need to discuss. Okay, in this way, uh,
Yes, sir.
yeah, can I go for next problem, or you need break?
So give 5 minutes. I will draw.
Yeah, so it is 9:55. I would like to take attendance for this period. Then we will join after 10 minutes or 15 minutes for the next class. Okay. 57 is the strength. Yeah, there are, yeah. So please take a break for